Hello everyone. Hello everyone. Welcome to Sankalp Learning Solution. I am Vijayashri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. Let us look at the question number 41. Which of the following formula name combinations is correct? Here 4 options are given. We have to identify the correct options here. So first one, option A, CuNH3 4 times SO4. Its name is tetramine copper 2 sulfate ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, let us check option A. Excuse me. Okay, option A. We will check the option A. Copper NH3 4 times SO4. Okay, here cation is, this is the complex cation. Cation ಯಾವುದು CuNH3 4 times and anion SO4 2 minus. Sulfate is the anion. So in order to balance this -2 charge, we have to assign +2 charge over this complex cation. Okay, complex cation has +2 charge and anion has -2 charge. Now we will find the oxidation state of this central metal atom or ion. Let X be the oxidation state of this central metal atom, copper. And amine is a neutral ligand and its oxidation state is 0. So we will calculate the oxidation state of copper now. X plus, there are 4 amine ligands. So we have to multiply 4 by 0. Why 0? Because amine is a neutral ligand. We have to equate this to +2. So x plus 4 into 0 is equal to +2. So x plus 0 is equal to 2 implies x equal to +2. Oxidation state of copper is +2. Let us check the name of this compound. There are 4 amine ligands, so we have to name it as tetramine. Then we have to name the central metal amine, copper, with its oxidation state is +2. So it is, then we have to name the anion, sulfate. So option A correct ಇದೆ. Incorrect ಅನ್ನ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು. ಆಪ್ಷನ್ ಎ ಕರೆಕ್ಟ್ ಇದೆ. ಇವಾಗ we have to check option B. Option B is ZnH2O 6 times SO4. Here anion is SO4 2 minus and cation is complex cation. It is ZnH2O 6 times anion ಗೆ -2 charge ಇರೋದ್ರಿಂದ, in order to balance this we have to put +2 charge over this copper complex cation. Now we will calculate the oxidation state of central metal atom. ಯಾವುದು zinc ಇದೆ. We will calculate the oxidation state of zinc now. Let X be the oxidation state of zinc and water. H2O is a neutral ligand, so its oxidation state is 0. Oxidation state over entire cation is +2. So how to calculate this? We have to calculate oxidation state of zinc, right? So X plus, there are 6 ligands. So 6 into 0. Why it is 0? Because H2O is neutral ligand, which is equal to plus 2. So X plus 0 equal to plus 2 implies X equal to 2. X equal to 2. So ಇವಾಗ ಇದರ ನೇಮ್ ಅನ್ನ ನೋಡೋಣ. There are 6 water ligands. So 6 ಅಂದ್ರೆ ಯಾವ ರೀತಿ ಪ್ರಿಫಿಕ್ಸ್ ಅನ್ನ ಬಳಸಬೇಕು? ಹೆಕ್ಸಾ. ಹೆಕ್ಸಾ ವಾಟರ್ ಇದ್ರೆ ಅದಕ್ಕೆ ಅಕ್ವಾ ಅಂತ ಹೇಳ್ತೀವಿ. ಹೆಕ್ಸಾ ಅಕ್ವಾ. Then we have to name central metal atom zinc. We have to specify the oxidation state, that is 2. So hexa aqua zinc 2. ಆಮೇಲೆ ಆನಯೋನ್ ಅನ್ನ ನೇಮ್ ಮಾಡಬೇಕು, ಅದು ಸಲ್ಫೇಟ್. ಸೊ ಕರೆಕ್ಟ್ ಇದೆಯಾ? ಹೆಕ್ಸಾ ಎಕ್ವಾ ಜಿಂಕ್ 2 ಸಲ್ಫೇಟ್. ಸೊ ಆಪ್ಷನ್ ಎ ಮತ್ತೆ ಆಪ್ಷನ್ ಬಿ ಎರಡೂ ಕರೆಕ್ಟ್ ಇದೆ. ಇವಾಗ ಆಪ್ಷನ್ ಸಿ ಅನ್ನ ಚೆಕ್ ಮಾಡೋಣ. ಆಪ್ಷನ್ ಸಿ FeCO5. ಇಲ್ಲಿ ಆನಯೋನ್ ಕೊಟ್ಟಿಲ್ಲ, ಕ್ಯಾಟಯೋನ್ ಮೇಲೆ ಚಾರ್ಜ್ ಅನ್ನು ಕೂಡ ಸ್ಪೆಸಿಫೈ ಮಾಡಿಲ್ಲ. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಚಾರ್ಜ್ ಓವರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ಯಾಟಯೋನ್ as 0. Here cation is FeCO 5 times with its oxidation state is 0. Okay, charge over this complex cation is 0. Now we will calculate the oxidation state of iron. Iron ಅಂದ್ರೆ ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಇದೆ. ಇದರ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. Take it as X. Then charge of carbonyl ligand is 0. It is a neutral ligand. ಹಾಗಾಗಿ ಇವಾಗ X plus 5 into 0 is equal to 0 ಆಗುತ್ತೆ. So X equal to 0 ಆಗುತ್ತೆ. Oxidation state of iron is 0 here. Now we will name this compound pentacarbonyl. 5 ಕಾರ್ಬೋನಿಲ್ ಲಿಗಂಡ್ ಇದೆ. ಸೊ 5 ಇದ್ದಾಗ ಪ್ರಿಫಿಕ್ಸ್ ಅನ್ನ ನಾವು ಪೆಂಟಾ ಅಂತ ಹೇಳ್ತೀವಿ. ಪೆಂಟಾಕಾರ್ಬೋನಿಲ್. ಆಮೇಲೆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಐರನ್ ಇದೆ. ಸೊ ಪೆಂಟಾಕಾರ್ಬೋನಿಲ್ ಐರನ್. ಐರನ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಎಷ್ಟಿದೆ? 0 ಇದೆ. ಬಟ್ ಇಲ್ಲಿ ಆಪ್ಷನ್ ಸಿ ದಲ್ಲಿ 3 ಇದೆ. ಸೊ ದಿಸ್ ಈಸ್ ಇನ್ಕರೆಕ್ಟ್. Oxidation state of iron is wrong here. So option C is incorrect. Option A, option B, both are correct. Option C is incorrect. So ನಮಗೆ ಇಲ್ಲೇ ಆನ್ಸರ್ ಸಿಕ್ಬಿಡ್ತು ಆಪ್ಷನ್ ಸಿ ಅಂತ. We will check the option D also. NiCO 4 times. Again ಇಲ್ಲಿ cation ಯಾವುದು? ಕಾಂಪ್ಲೆಕ್ಸ್ cation with oxidation state is 0. This is the cation. This is the cation. Nickel is the central metal atom. Okay, we will calculate the oxidation state of nickel. Let it be X. Carbonyl is a neutral ligand, so charge is 0. So X plus 4 times 0, which is equal to 0. Net charge over this complex is 0. So X plus 0 equal to 0 implies X equal to 0. ಹಾಗಿದ್ರೆ ನಿಕ್ಕೆಲ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಎಷ್ಟಿರುತ್ತೆ? 0 ಇರುತ್ತೆ. Oxidation state of nickel is 0. Now we will name this compound. First we have to name the ligand. There are 4 carbonyl ligands. 4 ಅಂದ್ರೆ ನಾವು ಪ್ರಿಫಿಕ್ಸ್ ಅನ್ನ ಟೆಟ್ರಾ ಅಂತ ಹೇಳ್ತೀವಿ. ಟೆಟ್ರಾ carbonyl. ಆಮೇಲೆ we have to name the central metal atom. So tetracarbonyl nickel with its oxidation state is 0 in the bracket. So ಇದು ಕೂಡ ಕರೆಕ್ಟ್ ಇದೆ. tetracarbonyl nickel 0. ಹಾಗಿದ್ರೆ ಇನ್ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಯಾವುದು ಅಂದ್ರೆ ಆಪ್ಷನ್ ಸಿ. ಹಾಗಿದ್ರೆ ನಮ್ಮ ಆನ್ಸರ್, ಅವರ್ ಆನ್ಸರ್ ಇಸ್ ಆಪ್ಷನ್ ಸಿ. ಥ್ಯಾಂಕ್ ಯು. Hello everyone. Welcome to Sankalp Learning Solution. I am Vijayshri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. Let us look at the question number 42. Which of the following system in octahedral complexes will have maximum number of unpaired electrons? Options. Option A FeH2O 6 times 2 plus. Option B COF6 3 minus. Option C NiNH3 6 times 2 plus. Option D MnH2O 6 times 2 plus. Which of the following systems in octahedral complex will have maximum number of unpaired electron? Maximum unpaired electron in the sense it is a high spin complex. Ligands are weak ligands, weak field ligands. Okay, let us check option A. Option A, FeH2O 6 times 2 plus. So let us see the oxidation state of central metal atom or ion. Let X be the oxidation state of iron here. Water is a neutral ligand. That's why charge over water is 0 and charge over the complex is +2. Let us calculate the oxidation state of iron here. X plus 6 times 0 is equal to 2 plus or +2. X plus 0 is equal to 2 implies X equal to +2. So oxidation state of iron here is +2. So here Fe2 plus. Fe2 plus is there. So configuration is electronic configuration. How to write this electronic configuration? Argon 4s0. Why it is 4s0? ಫಸ್ಟ್ ನಾನು ನ್ಯೂಟ್ರಲ್ ಐರನ್ ಇದು ಬರಿತೀನಿ ಆವಾಗ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. First I write the electronic configuration of neutral iron Fe. So total number of electrons 26. Atomic number is 26. So total number of electrons 26. We have to distribute this 26 electrons. It will be argon 4s0 4s2, argon 4s2 3d6, argon 4s2 3d6. Then Fe2 plus. Fe2 plus means 2 electrons are lost from neutral Fe. So its configuration will be argon 4s0. Why it is 4s0? Because 2 electrons are lost. So S subshell will have 0 electrons and 3d6. So 3d6 andre how many unpaired electrons? There are so totally 5 d orbitals. 1, 2, 3, 4, 5. So one orbital capacity is 2 electrons. We have to accommodate 6 electrons here. First we will put one electron in each orbital, then we will pair up. So 5 electrons got over. Remaining 1 electron we will pair up. So totally 3d6 configuration. Totally how many unpaired electrons are there? How many number of unpaired electrons are there? 4 unpaired electrons. 4 unpaired electrons. So firstly 4 unpaired electron ಇದೆ option A ದಲ್ಲಿ 4 unpaired electrons are there. Now we will check option B. 4 means 4 unpaired electrons ಅಂತ ಅರ್ಥ. Option B COF6 3 minus. So charge over the complex is 3 minus. We will calculate the oxidation state of cobalt here. Let the oxidation state of cobalt be X. F is a F carries charge -1. So ಏನಾಯ್ತು ಇವಾಗ X plus total there are 6 fluoride ligands. So 6 into -1 ಆಯ್ತು, which is equal to -3 ಆಯ್ತು. So X minus 6 equal to -3 implies X equal to +3. X equal to +3. Charge over oxidation state of cobalt is +3. So it is in the state CO +3. Right. So ಇವಾಗ ನಾವು ನ್ಯೂಟ್ರಲ್ ಕೋಬಾಲ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನ ಬರೆಯೋಣ. ಕೋಬಾಲ್ಟ್ atomic number is 27. So there are 27 electrons. We have to distribute 27 electrons. So electronic configuration of cobalt is argon 4s2, argon 4s2, 3d7, argon 4s2, 3d7. Cobalt +3 means 3 electrons are lost from neutral cobalt. Therefore, electronic configuration will be argon 4s0. 4s0 because 2 electrons are lost from s subshell and 1 electron is lost from d subshell. So I write it as 3d6. So it is a 3d6 configuration. Outer configuration is 3d6. So orbital alli baradre nanu. There are 5d orbitals. 1, 2, 3, 4, 5. ಈಗ third electron ನಾನು electron ಅನ್ನ ಬರೆದ್ರೆ 1, 2, 3, 4, 5. So one more electron I have to accommodate. I place here. So total number of unpaired electrons will be again 4. There are 4 number of unpaired electrons in option B. Now we will check the option C. Option C, nickel, NH3, 6 times, 2 plus. Charge over the complex is +2. Charge of ligand is 0 because amine is the neutral ligand. We have to calculate the oxidation state of nickel. Let it be X. X plus 6 times 0 is equal to 2 plus or +2. X plus 0 is equal to 2 implies X equal to 2. So Ni plus 2 ಆಗುತ್ತೆ ಇದು. Okay. Ni plus 2 ಇದೆ. ಫಸ್ಟ್ ನಾನು ನ್ಯೂಟ್ರಲ್ ನಿಕ್ಕೆಲ್ದು electronic configuration ಅನ್ನ ಬರೀತೀನಿ. Nickel atomic number is 26. So I have to distribute 20. Sorry, nickel atomic number is 28. 28 is the atomic number of nickel. I have to distribute 28 electrons. It is argon 4s2 ಆಮೇಲೆ 3d8 ಆಯ್ತು. argon 4s2 3d8 ಆಯ್ತು. nickel 2 plus because oxidation state of nickel is +2 here. So nickel 2 plus ಅಂದ್ರೆ 2 electron ಏನಾಗುತ್ತೆ ನ್ಯೂಟ್ರಲ್ ನಿಕ್ಕೆಲ್ ಇಂದ ಲಾಸ್ ಆಯ್ತು ಅಂತ ಅರ್ಥ ಅಲ್ವಾ. ಸೊ nickel 2 plus means argon 4s0. Why I have written 4s0 means 2 electrons are lost from s subshell. Then 3d8. It remains 3d8. So how many number of unpaired electrons? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 electrons are accommodated. Remaining 3 electrons I have to pair up. 1, 2, 3 like this. 1, 2, 3. Okay. How many number of unpaired electrons here? There are two unpaired electrons. ಇವೆರಡು unpaired electron ಆಗುತ್ತಲ್ವಾ? Totally two unpaired electrons. Now we will calculate the unpaired electrons in option D. Option D ದಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಕಂಪೌಂಡ್ ಏನಿದೆ MnH2O 6 times 2 plus. So charge over the complex is +2. Here ligand is water. It is a neutral ligand, so charge is 0. We have to calculate the oxidation state of Mn here. Let it be X. So X plus 6 times 0 is equal to 2 plus or +2, which implies X equal to 2 ಆಗುತ್ತೆ. Oxidation state of Mn is +2 ಆಗುತ್ತೆ. ಇವಾಗ ನ್ಯೂಟ್ರಲ್ Mn electronic configuration ಬರೆಯೋಣ. What is the atomic number of manganese? It is 25. We have to distribute 25 electrons. It will be argon, configuration will be argon 4s0. Sorry, it is 4s2. Argon 4s2. Then 3d5. Argon 4s2, 3d5. Correct idalva? 25. Correct ಇದೆ. Okay. ಇವಾಗ Mn +2 oxidation state is +2 ಅಂತ ಬಂದಿದೆ Mn. So Mn +2 ಅಂದ್ರೆ 2 electrons are lost from neutral Mn. Therefore, its electronic configuration will be argon 4s0. Why I have written 4s0? Because 2 electrons are lost from S subshell. Mn2 plus ಇದೆ ಅಲ್ವಾ? So 3d5 next. So ಇದನ್ನ diagram ಬರೆದಾಗ totally 5d orbitals, 1 2 3 4 5. Each orbital capacity is 2 electrons. So each orbital can accommodate, we can accommodate 2 electrons in each orbital. First we have to place one electron in each orbital. So 5 electrons are got 5 electrons got over. Total number of unpaired electrons here 5. There are 5 unpaired electrons in Mn2 plus. Hagagi, what is the question given here? Octahedral complexes will have maximum number of unpaired electrons. ಹಾಗಿದ್ರೆ ಯಾವುದರಲ್ಲಿ maximum unpaired electron ಇದೆ ಅಂತ ಆಯ್ತು? It is option D. So the right answer is option D, MnH2O 6 times 2 plus. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijayashri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. Let us look at the question number 43. The correct IUPAC name of trans PTCl2NH3 two times is options. There are four names are given. We have to identify the correct name. Okay. Now we will write the complex PTCl2 NH3 2. This is the given complex. Here ligands are NH3 amine. So idana amine anta ಹೇಳ್ತೀವಿ. It is amine. Then Cl, it is chlorido. Amine and chlorido. As we already know, we have to name the ligand alphabetically. Hagagi, first we have to name amine and then we have to name chlorido. Here central metal atom is platinum. Central metal atom is platinum. We have to calculate the oxidation state of this platinum. Here ಏನು ಬರ್ದಿಲ್ಲ ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ಚಾರ್ಜ್ ಅನ್ನ 0 ಅಂತ ತಗೋಬೇಕು. Charge over the complex is 0. Now we will calculate the oxidation state of platinum. Let it be X. Then chlorido. Chlorido ligand means it has charge -1. Amine ligand, it is a neutral ligand, so charge is 0. Therefore, oxidation state of platinum is X. X plus, there are two chlorido ligands, so 2 into -1 plus, there are two amine ligands, so 2 into 0, which is equal to 0. X minus 2 equal to 0 implies X equal to 2. So platinum is in +2 oxidation state. ಹಾಗಾಗಿ ಈಗ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ, ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಹೌ ಟು ನೇಮ್ ದಿಸ್? First we have to name the ligands. Ligands should be named alphabetically. So we have to name amine ligand first. How many amine ligands are there? Two amine ligands are there. So diamine anta ಹೇಳ್ತೀವಿ. Diamine. ಆಮೇಲೆ ಯಾವ್ದು ಲಿಗಂಡ್ ಇದೆ? ಕ್ಲೋರಿಡೋ ಲಿಗಂಡ್ ಇದೆ. How many chlorido ligands are there? Two chlorido ligands are there. So diamine. 2 ಅಂತ ಬಂದ್ರೆ ಪ್ರಿಫಿಕ್ಸ್ ಅನ್ನ ಡೈ ಅಂತ ಹೇಳಬೇಕು. Diamine, dichlorido. Then we have to name the central metal atom. What is that central metal atom? Platinum. With we have to specify oxidation state. What is the oxidation state of platinum? It is +2. We have to write it in the bracket. So diamine, dichlorido. ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡಿ ನೇಮ್ ಅನ್ನ. Diamine, dichlorido. Diamine, dichlorido, platinum. Then oxidation state is +2. Diamine, dichloro, platinum. ಆಮೇಲೆ ಯಾವ ಫಾರ್ಮ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ? ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಹಾಗಾಗಿ ಅದನ್ನ ನಾವು ಮುಂಚೆನೆ ಹಾಕಬೇಕು. ಟ್ರಾನ್ಸ್. ಓಕೆ, ಹಾಗಿದ್ರೆ ನೇಮ್ ಏನಾಯ್ತು? ಟ್ರಾನ್ಸ್ diamine dichlorido platinum 2. Which option matches to this name? Option A, trans diamine dichloro or chlorido. ಕ್ಲೋರೋವನ್ನು ನಾವು ಕ್ಲೋರೋ ಅಂತಾನು ಹೇಳ್ಬೋದು ಅಥವಾ ಕ್ಲೋರಿಡೋ ಅಂತಾನು ಹೇಳ್ಬೋದು. ಪ್ಲಾಟಿನಮ್ 2. ಸೊ ಇದು ಕರೆಕ್ಟ್ ಇದೆ. ಆಮೇಲೆ ಆಪ್ಷನ್ ಬಿ ಅನ್ನ ಚೆಕ್ ಮಾಡೋಣ. ಟ್ರಾನ್ಸ್ ಡೈಕ್ಲೋರೋ ಡೈಅಮೈನ್ ಅಂತ ಇದೆ. We have to name amine ligand first because we have to name ligand alphabetically. Here chloro comes first, so it is wrong option. We have to eliminate this. Then let us check the option C. Trans dichloroplatinum amine ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿ ನೋಡಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಅನ್ನೇ ಫಸ್ಟ್ ನೇಮ್ ಮಾಡಿದ್ದಾರೆ, ಅಮೈನ್ ಅನ್ನ ಆಮೇಲೆ ನೇಮ್ ಮಾಡಿದ್ದಾರೆ. ದಿಸ್ ಇಸ್ ರಾಂಗ್. ಆಮೇಲೆ ಆಪ್ಷನ್ ಡಿ ಸಿಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸಿಸ್ ಫಾರ್ಮ್ ಅನ್ನ ಕೊಟ್ಟೇ ಇಲ್ಲ ಇಲ್ಲಿ. ಸೊ ಆಪ್ಷನ್ ಡಿ ರಾಂಗ್. ಸೊ ದ ರೈಟ್ ಆನ್ಸರ್ ಈಸ್ ಆಪ್ಷನ್ ಎ. ಇಲ್ಲಿ ಕ್ಲೋರೋ ಮತ್ತೆ ಕ್ಲೋರಿಡೋ ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ, ಬೋತ್ ಆರ್ ಸೇಮ್. ಓಕೆ, ಕ್ಲೋರೋ ಅಂತಾನು ಹೇಳ್ತಾರೆ, ಕ್ಲೋರಿಡೋ ಅಂತಾನು ಹೇಳ್ತಾರೆ. ದ ಕ್ಲೋಸೆಸ್ಟ್ ಆನ್ಸರ್ ಇಸ್ ಆಪ್ಷನ್ ಎ, ಟ್ರಾನ್ಸ್ ಡೈಅಮೈನ್ ಡೈಕ್ಲೋರೋ ಪ್ಲಾಟಿನಮ್ 2 is the right answer. Option A is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijayashri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. Let us look at the question number 44. The CFSC, the crystal field stabilization energy for CrCl6 3 minus is 14,400 per centimeter. The CFSC for CrH2O 6 times 3 plus will be approximately options. Option A 16,000 per centimeter, option B 17,000 per centimeter, option C 18,000 per centimeter, option D 19,200 per centimeter. Okay, we will understand first the question. The CFSC for CrCl63 minus is 14,400 per centimeter. So what we are given first? ಫಸ್ಟ್ ನಾವು ಏನನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಬರೆಯೋಣ. ಗಿವನ್ CFSC ಅಂದ್ರೆ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಟೆಬಿಲೈಸೇಷನ್ ಎನರ್ಜಿ, CFSC ಫಾರ್ CrCl6 3 minus which is equal to 14,400 per centimeter. Similarly for CrH2O 6 times 3 plus will be question mark. This is the question mark. So to calculate CFSC, we have to identify the oxidation state of central metal atom. Okay, ಇಲ್ಲಿ oxidation state ಯಾವುದು? Chromium is the central metal ion here. We have to identify the oxidation state of chromium in both complex. Okay, first ನಾನು ಇಲ್ಲಿ ಬರೀತೀನಿ oxidation state of chromium. ಇಲ್ಲಿ net charge -3 ಇದೆ for ಯಾವುದು? CrCl6 3 minus. Oxidation state of chromium here will be X. Then Cl chloride ligand charge ಏನಿರುತ್ತೆ? -1 ಇರುತ್ತೆ. Net charge over the complex is -3. 3 minus ಇದೆ. So oxidation state of chromium X plus 6 into -1. Why it is -1? Because charge of chloride ligand is -1. There are 6 chloride ligands. So 6 multiplied by -1, which is equal to -3, implies X equal to +3. X equal to +3. Here chromium is in +3 oxidation state. +3 oxidation state. Okay. Similarly, we have to calculate the oxidation state of chromium in CrH2O6 times +3 complex. Okay, ಈಗ ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ CrH2O 6 times +3 complex. Oxidation state of chromium be X. Water is a neutral ligand, so charge is 0. Net charge over the complex is +3. Okay, ಇವಾಗ X plus 6 times 0 is equal to +3, implies X equal to +3. So in both complex, chromium is in +3 oxidation state. Okay, in both complexes, chromium is in +3 oxidation state. So what is the oxidation state of chromium here? +3 in both complexes, right? Hagidre, what is the electronic configuration of chromium +3? Neutral chromium has 24 electrons. Chromium +3 means 3 electrons lost from neutral chromium, right? So there will be 21 electrons. How to distribute this 21 electron? It will be argon 4s0, then 3d3. Okay, so neutral do Cr neutral chromium do argon 4s2 3d4. It is the electronic configuration of neutral chromium, and chromium plus 3 means 3 electrons are lost from neutral chromium. Then configuration will be argon 4s0 3d3. It is the electronic configuration of chromium plus 3. Right. Now, what we are given here is, it is a octahedral complex. Illi nodidre nimge gottagatte. There are 6 ligands. There are 6 ligands means it is a octahedral complex. It is a octahedral complex. So how electrons are distributed? D electrons are distributed. Crystal field splitting theory ಅನ್ನು apply ಮಾಡಿದ್ರೆ, crystal field theory ಅನ್ನು apply ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ. Here you can see the image. Here you can see the image. Here crystal field theory. Illi nodi, degenerate d orbitals get splitted into 2 Eg orbitals and 3 T2G orbitals. Initially, before approaching ligand, there are 5 degenerate orbitals in chromium plus 3, right? As ligand approaches, it gets splitted into 5 Eg orbitals and 3 T2G lower energy orbitals. Okay. ಇದೆಲ್ಲ ನಿಮಗೆ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಥಿಯರಿ, ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಥಿಯರಿಯಲ್ಲೇ ಗೊತ್ತಿದೆ. ಆಕ್ಟಾಹೆಡ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ದು ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಥಿಯರಿ ಬಗ್ಗೆ ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ. ಇವಾಗ ಹೌ ಟು ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಇಲೆಕ್ಟ್ರಾನ್ಸ್, ಸೊ ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನಾಯ್ತು ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಥಿಯರಿ. Cr plus 3 means electronic configuration will be T2G3. So 3 electrons will be occupying T2G orbitals, 3 T2G orbitals. Then in Eg orbitals there will be 0 electrons. Higher energy Eg orbital alli 0 electron irutte. Amele TTG orbital alli 3 electron irutte. D3 configuration alva. So 3 d electrons will be in T2G orbitals and 0 electrons will be in Eg orbitals. So configuration will be T2G3 Eg0 according to the crystal field theory. Okay. Now what we have to calculate? CFSC alva, crystal field splitting energy. So illi ಒಂದು formula ಇದೆ ನೋಡಿ. Crystal field splitting energy. Crystal field splitting energy for octahedral complex is yes, okay, number of T2G electrons number of T2G electrons into 2.5 into delta naught. 2.5 into delta 2 by 5 into delta naught. 2 by 5 andre 2 by 5 ಮಾಡಿದಾಗ it is 0.4. 0.4 into delta naught. Delta naught means crystal field splitting energy for octahedral complex minus number of electrons in Eg, number of electrons in Eg into ಇಲ್ಲಿ ನೋಡಿ ಪ್ಲಸ್ 3/5 ಇಂಟು ಡೆಲ್ಟಾ ನಾಟ್ ಇದೆ. ಪ್ಲಸ್ 3/5 ಅಂದ್ರೆ 0.6 ಇಂಟು ಡೆಲ್ಟಾ ನಾಟ್ ಆಗುತ್ತೆ. ಪ್ಲಸ್ 3/5 ಇಂಟು ಡೆಲ್ಟಾ ನಾಟ್ ಇದೆ. It will be 0.6 into delta naught ಆಗುತ್ತೆ. So now what we are given here is ಏನು ಡೆಲ್ಟಾ ನಾಟ್ ಅನ್ನ ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿದ್ದಾರೆ. We are given delta naught as 14,400 ಅಂತ ಆಲ್ರೆಡಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. ಸೊ 14,400 is the delta naught, right? ಸೊ ಇವಾಗ ಇದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡೋಣ. ನಂಬರ್ ಆಫ್ T2G electrons, T2G electrons 3 electrons ಇದೆ ಅಂತ ಹೇಳಿದ್ದೇನಲ್ವಾ. ಇಲ್ಲಿ T2G ಆರ್ಬಿಟಲ್ಸ್ ಅಲ್ಲಿ 3 electrons ಆಕ್ಯುಪೈ ಆಗುತ್ತೆ. ಸೊ 3 ಇಂಟು 0.4 ಇಂಟು ಡೆಲ್ಟಾ ನಾಟ್ ಅಂದ್ರೆ ಎಷ್ಟು, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 14,400. We are given 14,400 minus number of electrons in EG ಅಂದ್ರೆ 0. ಇಲ್ಲಿ EG ದಲ್ಲಿ 0 electrons ಇವೆ ಅಲ್ವಾ. 0 into something is 0. So second term ಏನಾಗುತ್ತೆ, entire term will be 0 ಆಗುತ್ತೆ. So I am going to erase this. So ಇದನ್ನ simplify ಮಾಡಿದಾಗ it will become 0.4 into 3 ಅಂದ್ರೆ 1.2 into ಇದು 14,400 ಅಂತ ಆಗುತ್ತೆ. Just to remember this number. Sorry, just count this. Okay. Hello everyone, welcome to Sankalp Learning Solution. I am Vijayshri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. We are discussing 44th question. If CFSE for CrCl6 3 minus is 14,400 per centimeter, the CFSE for CrH2O 6 times 3 plus will be approximately option A 16,000 per centimeter, option B 17,000 per centimeter, option C 18,000 per centimeter, and option D 19,200 per centimeter. So here we are given crystal field stabilization energy for CrCl6 3 minus complex. Okay, it is given as 14,400 per centimeter. We need to calculate CFSA and the crystal field stabilization energy for CrH2O 6 times 3 plus. We have to calculate this. Before going to calculate CFSE, first we have to identify the oxidation state of chromium here. Here in both complex, chromium is the central metal atom, right? What is the oxidation state of chromium? Let it be X. ಇಲ್ಲಿ CrCl6 3 minus. ಇದರಲ್ಲಿ oxidation state of chromium be X. Then charge on the chlorine is -1. So oxidation state is X plus 6 into -1. It will be equal to -3, which implies X equal to +3. X equal to +3. Okay. Therefore, oxidation state of chromium here is +3. So now calculate the oxidation state of chromium in water. Okay. It will be CrH2O 6 times 3 plus. Let the oxidation state of chromium be X. Water is a neutral ligand, therefore charge over water is 0. Therefore, X plus 6 into 0 equal to +3 implies X equal to +3. Therefore, here also oxidation state is +3. Oxidation state is +3. In the both complex, oxidation state of chromium is +3. Right. ಹಾಗಾಗಿ chromium plus 3 electronic configuration ಏನು? So neutral chromium do electronic configuration atomic number of chromium is 24. So its electronic configuration will be argon 4s2 then 3d4. This is the electronic configuration of neutral chromium. When chromium plus 3 means 3 electrons are lost from neutral chromium. 3 electrons loss ಆಯ್ತು ಅಂದ್ರೆ it will be argon and 4s2 ದಿಂದ 2 electron ಹೋಗುತ್ತೆ. It will be 4s0 and one more electron we have to eliminate, that will be from D subshell. It will be 3d3. 3d4 ಇದ್ದಿದ್ದು ಇಲ್ಲಿ 3d3 ಆಗುತ್ತೆ. Totally 3 electrons are lost from neutral chromium. It will become chromium plus 3. Now this is the electronic configuration of chromium plus 3. So according to crystal field theory, electronic configuration ಅನ್ನು ನಾವು ಹೇಗೆ ಬರಿತೀವಿ? Cr plus 3 ಅಂದ್ರೆ it will be T2G3 and Eg0. This is the electronic configuration according to crystal field theory. ಯಾಕೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ನೀವು ಒಂದ್ಸಲ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಥಿಯರಿಯನ್ನ ನೋಡಿದಾಗ in octahedral complexes before ligand approach ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ 5 d orbital energy ಕೂಡ ಏನಿರುತ್ತೆ? ಸೇಮ್ ಇರುತ್ತೆ, degenerate ಇರುತ್ತೆ. Here you can see degenerate d orbitals. As ligand approaches, this energy gets split into two sets. ಒಂದು T2G set ಆಗುತ್ತೆ, ಇನ್ನೊಂದು Eg set ಆಗುತ್ತೆ. Okay, T2G set contains 3 d orbitals and Eg set contains 2 d orbitals. Okay, D3 configuration ಇದೆ ಅಂದ್ರೆ since D3 configuration 3 electrons will occupy T2G orbitals. 3 electrons will occupy T2G orbitals. ಇಲ್ಲಿ 3 electrons T2G orbital ಅಲ್ಲಿ occupy ಆಗುತ್ತೆ. So ಇಲ್ಲಿ T2G orbital ಅಲ್ಲಿ ಇರುವಂತ electrons 3 ಆಗುತ್ತೆ and number of electrons in Eg set will be 0. So T2G dalli 3 electrons irutte, that's why I have written T2G3, and number of electrons in the Eg set will be 0, that's why I have written Eg0. So I hope you have understood the basic things regarding crystal field theory. And ಈ ಒಂದು ಇಮೇಜ್ ಸಪೋರ್ಟಿವ್ ಇಮೇಜ್ ಅನ್ನ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಇವಾಗ electronic configuration ಅನ್ನ ನಾವು ಬರೆದ್ವಿ. There is one formula which relates crystal field splitting energy and crystal field stabilization energy. What is that formula? CFSE. That means crystal field stabilization energy, which is equal to number of T2G electrons into ಇಲ್ಲಿ T2G electrons ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ degenerate energy ಇಂದ 2.5 into delta naught less ಆಗಿದೆ. So 2.2 by 5, not 2.5, it is 2 by 5 means it is 0.4 into delta naught. Delta naught ಅಂದ್ರೆ ಇದು crystal field splitting energy. Okay, minus a number of electrons, number of Eg electrons, number of Eg electrons, number of Eg electrons into ಇಲ್ಲಿ 3 by 5 into delta naught. 3 by 5 ಅಂದ್ರೆ 0.6 into delta naught. Delta naught ಅಂದ್ರೆ crystal field splitting energy. CFSE ಅಂದ್ರೆ crystal field stabilization energy. Crystal field stabilization energy is given as 14,400. Therefore 14,400 is equal to 14,400 is equal to number of T2G electrons means 3 electrons. There are 3 electrons in T2G orbitals anta helidini. Illi electronic configuration nodidre gottagutte. It will be 3 into 0.4 into delta naught. We don't know crystal field splitting energy. Keep it as delta naught only. Minus number of electrons in EG set. There are 0 electrons in EG set. So next term entire will be 0. Next entire term will be 0 because 0 multiplied by anything will be 0. Number of EG electrons andre illi 0 irutte alva. So next term will be 0. So it will be 0.4 into 3 andre 1.2 into delta naught is equal to 14,400 implies delta naught is equal to 14,000 400 divided by 1.2, it will be 14,400 divided by 1.2 ಮಾಡಿದಾಗ it will be 12,000 per centimeter. So answer will be 12,000 per centimeter. Delta naught is equal to 12,000 per centimeter. Right? Okay, we have calculated crystal field splitting energy. What we need to calculate? Crystal field stabilization energy for this complex, second complex, CrH2O 6 times 3 plus complex. Okay, I am going to erase this. Just note ಮಾಡ್ಕೊಳ್ಳಿ ಇದನ್ನ. Just remember this number, delta naught. Okay. Delta naught equal to 12,000 per centimeter. Right. Now, compare the ligands according to spectrochemical series. Compare the ligand strength. So, chlorine, then fluoride, then H2O, then ಇಲ್ಲಿ ಬರಿತೀನಿ, then ammonia, then CM. So cyanide ligand is the strongest ligand alva. Ligand strength anna bardaga cyanide ligand is the strongest ligand. Water comes under strong field ligand also. Water is a strong field ligand than chlorine. Illi nodi. Here in this compound, chloride ligand is given, and here water ligand is given. So according to this series, strength water is a stronger ligand than chloride. Okay, water is a stronger ligand than chloro ligand anta ಹೇಳ್ತೀವಿ. Water is a stronger ligand than chloro. Okay. So water is a stronger ligand than chloro means, which implies delta naught for water. Delta naught for water is greater than delta naught for Cl minus. Alva? So crystal field splitting energy kuda directly proportional ide. Delta naught directly proportional to ligand strength. Crystal field splitting energy directly proportional to ligand strength. Therefore, crystal field splitting energy for water, ligand as a water, is greater than crystal field splitting energy when chloro is a ligand. The delta naught for water is greater than delta naught for chloro anta baribodu. Right? Illi nodi, experimentally, as per the experimental data for Cr3 complex, CrCl6 3 minus ಗೆ ಎಷ್ಟು ಬಂದಿದೆ? Approximately 12,000 per centimeter ಅಂತ ಇದೆ. Right? In the same way, CrH2O 6 times 3 plus It is approximately 16,000 per centimeter. Okay, it is the approximate value, approximate experimental value. Okay, now remember this number, which is equal to delta naught, which is equal to delta naught for this. So note down this. I am going to erase this. What is the concept here is water is stronger ligand than chloroligand. Okay, therefore crystal field splitting energy for water is greater than crystal field splitting energy for chloroligand. ಹಾಗಾಗಿ ಇಲ್ಲಿ ಡೆಲ್ಟಾ ನೋಟ್ ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. Delta naught for this complex is more. Okay, delta naught is more here. Experimental value approximately it is 16,000 per centimeter irutte. Okay, for this complex CrH2O 6 times 3 plus. I am going to erase this. Delta naught for CrH2O 6 times 3 plus will be, which is equal to 16,000 per centimeter. Okay, 16,000 per centimeter. So ಇದಕ್ಕಿಂತ CrCl6 3 minus complex ಗಿಂತ ಡೆಲ್ಟಾ ನಾಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್. ಹಾಗಾಗಿ ವಾಟ್ ಈಸ್ ದ ಫಾರ್ಮುಲಾ? CFSE. CFSE is equal to, ನಾನು ಆಲ್ರೆಡಿ ಹೇಳ್ದ ಹಾಗೆ ಸೆಕೆಂಡ್ ಟರ್ಮ್ 0 ಆಗುತ್ತೆ ಅಲ್ವಾ, ಇವಾಗ ನಂಬರ್ ಆಫ್ electrons in T2G into, it will be 0.4 into delta naught. Okay, now for Cr plus 3 configuration ಏನಾಯ್ತು, argon 4s0 3d3 ಅಲ್ವಾ. ಸೊ ಫಾರ್ D3 ಕಾಂಪ್ಲೆಕ್ಸ್ ನಾನು ಆಲ್ರೆಡಿ ಇಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನ ಬರ್ದಿದ್ದೇನೆ, ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು T2G3 Eg0 ಇರುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ 3 into 0.4 into ಡೆಲ್ಟಾ ನಾಟ್ ಎಷ್ಟಿದೆ, delta naught for CrH2O 6 times it is 16,000 per centimeter, which is equal to 1.2 into 16,000. 1.2 into 16,000, it will be approximately equal to 1.2 into 16,000 ಮಾಡಿದಾಗ it will be approximately 19,200 per centimeter. 19,200 per centimeter. Okay, so the right answer here is option D, 19,200 per centimeter. Option D is the correct answer here. So CFSE, crystal field stabilization energy for CrH2O 6 times 3 plus will be approximately 19,200 per centimeter. Thank you. Hello everyone, welcome to Sankalp Learning Solution. I am Vijayshri. We are discussing Lba-Kcet questions of the chapter Coordination Compounds. Let us look at the question number 45. The complex hexamine cobalt 3 chloride on ionization gives dash number of ions in solution. Options: option A 2, option B 3, option C 4, and option D 5. Complex hexamine cobalt 3 chloride. So what is the formula? Hexamine means ligand is amine. There are 6 amine ligands. So NH3 6 times. Okay. Cobalt 3. Andre central metal atom is cobalt. Then chloride. Cobalt 3 chloride. Chloride means here chloride is the anion. This is the cation, complex cation, hexamine, cobalt 3, which is indicating complex cation. Chloride is anion. Oh, cobalt plus 3 ಅಂದ್ರೆ ಇವಾಗ ನಾವು ಫಸ್ಟ್ ಎಷ್ಟು ಕ್ಲೋರೈಡ್ ಬೇಕು ಅಂತ ನೋಡೋಣ ಅಲ್ವಾ. ಸೊ ಇಲ್ಲಿ ಕ್ಲೋರೈಡ್ ಅಂತ ನಾನು ಬರ್ದಿಡ್ತೇನೆ. ಕೋಬಾಲ್ಟ್ ಪ್ಲಸ್ 3. So oxidation state of cobalt is plus 3. Charge over the complex we have to calculate. Then we can give the number of chloride anions. Okay. Now plus 3 means 3 only. 3 plus 6 times 0. Here 0. Amine ligand carries charge 0, which is equal to ಏನಾಯ್ತು, which is equal to 3 ಆಯ್ತು ಅಲ್ವಾ. Therefore charge over complex is plus 3. Charge over this complex is plus 3. Okay. In order to balance this plus 3, so charge on one chloride is minus 1. One chloride ಮೇಲೆ minus 1. So ಇವಾಗ plus 3 ಅನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ we have to put 3 chloride anions. So 3Cl minus and plus 3 both get balanced. So ಇಲ್ಲಿ charge plus 3 ಇರೋದ್ರಿಂದ I have to assign 3 chloride anions. I hope it is clear. Okay, this is the formula. ಇಲ್ಲಿ ವರ್ಡ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಾವು ಫಾರ್ಮುಲಾವನ್ನ ಮಾಡಿದ್ವಿ ಇವಾಗ. ಸೊ ಇದರ ಅಯೋನೈಸೇಷನ್ ಅನ್ನ ನೋಡೋಣ. ಅಯೋನೈಸೇಷನ್, ಕನ್ಸಿಡರ್ ದ ಅಯೋನೈಸೇಷನ್ ಆಫ್ this particular complex. Hexamine cobalt 3 chloride. Okay. NH3 6 times Cl3. Okay. Cl3 is ionization ಆದಾಗ this complex is not going to ionize. This complex cation is not going to ionization. Okay, ಇದು CONH3 6 times plus 3. It is a complex ion, so further ionization is not possible here. Plus ಇದು ಈ coordination pair ಇಂದ ಹೊರಗಡೆ ಇರೋದು ionize ಆಗುತ್ತೆ. 3 ಕ್ಲೋರಿನ್ ಆಟಮ್ಸ್ ಇದೆ ಅಲ್ವಾ. ಸೊ ಇಟ್ ಈಸ್ 3Cl minus ಆಗುತ್ತೆ. ಓಕೆ. So this is a complex cation. These are 3 anions. This is 1 cation. Therefore 1 cation plus 3 anions. So total number of ions 1 plus 3 will be 4. 1 plus 3 will be 4. So the right answer here is option C, 4. Option C is the correct answer. One plus 3, which is equal to 4. Thank you.